Students, in this video I explain important problems in differentiation chapter. So here we have function y is equals to square root of sin x plus y. Then dy by dx is equals to, here we have four options. Now here we have y is equals to root of sin x plus y. Now here we take square on both sides, we get y square is equals to root and square is cancelled, sin x plus y. See, next step, differentiate with respect to x on both sides. See, derivative of y square, differentiate with respect to x on both sides. Derivative of y square is 2y into dy by dx is equals to derivative of sin x is cos x plus derivative of y is dy by dx. Now here we have right hand side is dy by dx. This dy by dx take to left hand side, we get minus dy by dx. 2y into dy by dx minus dy by dx is equals to cos x. See, now here we have dy by dx, here also we have dy by dx. Now here dy by dx, take dy by dx common, dy by dx of 2y minus 1 is equals to cos x. Next, this part take to denominator. This implies dy by dx is equals to cos x divided by 2y minus 1. 2y cos x here options, 1 minus 2y, here we have 2y minus 1 option, D is correct. See, this result we can also in another form, you can directly differentiate dy by dx is equals to derivative of this result 1 divided by 2 into root of sin x plus y into derivative of sin x plus y is cos x plus dy by dx. That method is a lengthy process, that's why I consider this method. Okay. See, here we have the curve root x plus root y is equals to 1. Now here differentiate with respect to x. Say derivative of root x 1 by 2 root x plus, see here with respect to x, that's why derivative of x is, we get 1, 1 into 1 is 1. Derivative of root y can be written as 1 by 2 root of y into dy by dx is equals to derivative of dy by dx of 1 is constant term 0. Next, here we have 1 by 2 root x. This part first term, take this result to right hand side, we get negative of this term 1 by 2 root of y into dy by dx is equals to minus 1 by 2 into root x. Next, take cross multiplication form, or this 2 root y take to right hand side, we get dy by dx is equals to 2 root y into 1 minus 2 root y divided by 2 root x. So here 2 get cancelled is equals to minus root y divided by root x, the value of dy by dx. Now here we have to find dy by dx at 1 by 4 comma 1 by 4, means x is 1 by 4, y is equals to 1 by 4 is equals to, here we have numerator root y is 1 by 4 minus of root of 1 by 4 divided by root of 1 by 4. Say this result is equals to minus of root of 1 by 4 is, root of 1 is 1, root of 4 is 2, 1 by 2, denominator also we get same 1 by 2. Or you can directly cancel this result, root of 1 by 4, root of 1 by 4 is cancelled, we get 1 into minus, or see 1 by 2 get cancelled, see is equals to minus 1. See, minus 1 is the required solution. Option C is correct. See, here we have function y is equals to tan inverse of sin x divided by 1 plus cos x. See, now here we have sin, we know the sin 2x is a form, sin 2x is equals to 2 sin x into cos x. See, another one is 1 plus cos 2x can be written as 2 cos square x. But now here we have sin 1x. See, now here apply off angles form, tan inverse of sin x can be written as 2 sin of x by 2 into cos of x by 2 Denominator here we have 1 plus cos x. Now apply in half angles form. 2 cos square of x by 2. Now observe here we have numerator cos of x by 2 and denominator one term cos of x by 2 is cancelled. Then 2 get cancelled. Remaining result here we have sin of x by 2 divided by cos of x by 2. Tan inverse of sin by cos can be written as tan of x by 2. Here we have sin by cos. Sin by cos can be written as tan x by 2. Next, tan inverse tan is get cancelled. Here we get x by 2 is equals to y. Now here we have to find the value of dy by dx. Now here differentiate with respect to x. D by dx of y is equals to d by dx of x by 2. 1 by 2 is constant term. D by dx of x is 1. 1 into 1 by 2 is equals to 1 by 2. 1 by 2 is the required solution. Option B is correct. See, here we have y is equals to x to the power x. Then find dy by dx. Here we have dy by dx is here we have 4 options. We know already we discussed this result in a theory class. That is x to the power x into 1 plus log x. They will ask in this basis power form u to the power v. See, y is equals to u to the power v. Suppose given result in this form u by v. Now here we take log on both sides. That is the procedure to solve power form u by v form. Now here we have, I will explain one result, x to the power x. This is in 1992 question paper problem. Y is equals to x to the power x. Now here take log on both sides. Log y is equals to log of x to the power x. See here a to the power b form, b into log x. This result can be written as x into log x is equals to log y. Now here differentiate with respect to x on both sides. We get 1 by y into dy by dx is equals to, here we have u into v form, product rule result. Now apply product rule formula. X into derivative of log x is 1 by x plus log x into derivative of x is 1. Next, here observe here x divided by x gets cancelled. We get 1 here. Then 1 by y here we take cross multiplication takes to right hand side. Dy by dx is equals to y into, here we have one first term is 1 plus log x into 1 is log x. Next, substitute the value of y. Y is equals to given term x to the power x. Therefore, dy by dx is equals to x to the power x 1 plus log x. See, option C is correct. See, here we have xy is equals to x plus y. Now here find the value of dy by dx. We have to find in the dy by dx result. Y, this term take to left hand side. X y minus y is equals to x. Next, take common y. Y of x minus 1 is equals to x. Next, this implies y is equals to take to denominator right hand side. Here we get x divided by x minus 1. Next, here differentiate with respect to x. Here we have y variable, right hand side we have x variable terms. Easily we get that answer. Differentiate with respect to x on both sides. D by dx of y is equals to, means dy by dx is equals to d by dx of u by v formula. Denominator into derivative of u. You see here u by v form, denominator into derivative of numerator minus numerator into derivative of denominator, means denominator into derivative of numerator. D by dx of x is 1 minus x into derivative of denominator is 1 whole divided by, see constant term becomes 0, x minus 1 whole square. Now simplify the result. X minus 1 into 1 is x minus 1, x into 1 is x minus x divided by x minus 1 whole square. See here plus x minus x gets cancelled, minus 1 divided by x minus 1 whole square. See, option D is correct. See, here we have one important form, very important result. If y is equals to root of x plus x, root x plus root of x plus root of x plus to infinity, then dy by dx. See, this is a result. Here we have one standard result. Y is equals to, or y is equals to root of f of x plus root of f of x plus root of f of x plus so on to infinity, then dy by dx is equals to f dash of x divided by 2y minus 1. F dash of x divided by 2y minus 1. We can use this standard result. See, now here we have f of x. In the place of here we have f of x. In place of f of x, here we have x term. See, f of x is equals to x. Derivative of this result means f dash of x is equals to 1. Now here directly you substitute the result dy by dx. Here we have f dash of x divided to 2y minus 1. F dash of x value is 1 divided by 2y minus 1. See, option, observe here, option B is correct. This is using standard result method. Suppose you can use directly this result. See, y is equals to root of, see, the result is repeated to infinity form, that's why, so this is another method, or y is equals to root of x plus, we consider directly y because it is in n forms, means infinity terms, that's why here consider y plus root of x plus y. Now take square on both sides, we get y square is equals to square and root is cancelled, x plus y. Next, differentiate this result. Differentiate with respect to x. Differentiate with respect to x. Here we get 2y into dy by dx is equals to 1. Right hand side, derivative of x is 1. Derivative of y is dy by dx. Next, dy by dx. This term take to left hand side. We get minus dy by dx. 2y dy by dx minus dy by dx is equals to 1. You see, in CET, in the examination point of view, no need to write all these steps. You know the concept, you can directly check the result. See, here we consider y is equals to root of x plus y, then square on both sides, we get direct y square is equals to x plus y, then differentiate. Here we get y square, what happens to y into dy by dx? You can directly consider, suppose you take left hand side, we get minus, dy by dx is common, 2y minus 1 is equals to 1. Then take to denominator, what happens 1 divided by 2y minus 1, that is the required answer. Option B is correct. Suppose you use standard result. See, you recall the result, this result in the form of standard result, y is equals to root of f of x plus root of f of x to infinity form. That result can be as dy by dx is equals to shortcut form f dash of x divided by 2y minus 1. Directly find f of x term. Derivative of the result is here. We get x is derivative of x is 1 divided by 2y minus 1. Check the result. Option here we have option B is correct. Suppose they will give in the form in the place of x is cos x. See, x, suppose y f of x is cos x, the derivative of cos x is minus sin x. Minus sin x divided by 2y minus 1. Okay, similarly you can find remaining all results. See, that is standard form of this result. Dy by dx is equals to f dash of x divided by 2y minus 1. Now here dy by dx, take common, 2y minus 1 is equals to 1. This implies final result dy by dx is equals to 1 by 2y minus 1. So let's try another example. Here we have y is equals to root of sin x plus root of sin x plus root of sin x to infinity. Then dy by dx is. See, here also we can use a standard result. Y is equals to root of f of x plus root of f of x to infinity. Then dy by dx is equals to f dash of x divided by 2y minus 1. Now here we have f of x. See, f of x in this result, sin x. See, derivative of sin x, f dash of x is equals to cos x. See, now substitute, instead of this is substitute cos x, in the place of f dash of x we get cos x divided by 2y minus 1. See, option C is correct. See, here we have the expression of dy by dx of the function y is equals to a to the power x, a to the power x, a to the power x to infinity. Here we have to find dy by dx. See, a to the power x, a to the power x, a to the power x, so on to infinity. Now I consider this is up to infinity term results. That's why I consider y is equals to a to the power x to the power y. See, now observe here, this is in the form of power method, means u to the power v results forms. See, now here we have constant term is a. That's why I split this result a to the power x to the power y. I write this term x to the power y. Okay, then I take, see, given result in the form of power form u to the power v result form. Now here we apply logarithmic form. Take log on both sides. Log y is equals to log of a to the power b can be written as b into log a, means x to the power y into log a. See, again this result in the form of u to the power v. That's why I take again logarithmic form. Take log on both sides, again log of log y is equals to log of this term. See, here we have two terms. Log of ab can be written as log a plus log b. Log of log a, here we get the term. Log of ab can be written as log a plus log b. B is log a. Next, here we have x to the power y. This result can be written as y into log x plus log of log a. Get cancelled. Here same term, log of log y. Now here differentiate with respect to x on both sides. See, derivative of this term 1 divided by log y, log of this function into derivative. See, derivative of this function is, derivative log means 1 by x form. Now here we have in the place of x is log y, 1 by log y into derivative of log y is 1 by y into dy by dx is equals to u into v formula. Apply product rule. Y into derivative of log x is 1 by x plus log x into derivative of y is dy by dx plus derivative of constant term, here we have a, constant term becomes 0. Now here we have right hand side dy by dx. This term take to left hand side, we get minus of the term 1 by y into log y. I take common directly, minus log x into dy by dx. So take this term to left hand side, we get minus, then take common dy by dx. Here we get 1 by y into log y minus log x into dy by dx is equals to, here we have one more term y by x plus 0 is y by x. Next, here we have denominator y log y. Here we have denominator is 1. Take LCM of these two terms, we get y into log y. Y log y, y log y. See here 1 minus y log y into log x. Here 1 into this term, we get, already we have log x. Y into log y, y log y log x is into dy by dx is equals to y by x. Then the classification, this is a transpose to right hand side, we get dy by dx. This implies, see, y log y into y square log y, and the transformation y 1 minus y log x into x, or you can write x into 1 minus y into log y log x, or log x into log y. See options. Option C is correct. Y square log y divided by x times of 1 minus y log x, or log x log y is the required solution for this result. Example, if y is equals to x to the power x to the power x so on to infinity, then dy by dx is, here we have 4 options. Now here also in the form of power results. See, y is equals to, this result can be written as x to the power x to the power x to the power x to infinity. Y is equals to x to the power y, because to infinity forms, that's why here consider y is equals to x to the power y. Next step, take log on both sides. Log y is equals to y into log x. I consider directly a to the power b. Log of a to the power b can be written as b into log a, means y into log x. Now differentiate with respect to x. With respect to x, 1 by y into dy by dx is equals to u into v formula. Y into derivative of log x is 1 by x plus log x into derivative of y is dy by dx. See, derivative of log x, see here, into derivative of y is dy by dx. U into v form, first function into derivative of log x 1 by x plus log x into derivative of y is dy by dx. Now this term transpose, see, take to left hand side, you get minus log x into dy by dx. 1 by y into dy by dx minus log x into dy by dx is equals to remaining term. Here right hand side result is y by x. Next, dy by dx, here also we have dy by dx. Now take dy by dx common, dy by dx of 1 by y minus log x is y by x. Next, take LCM, that is y is LCM. Here we have denominator 1 minus y log x divided by y is equals to y by x. Then take cross multiplication form, dy by dx is equals to y into y square divided by x into this term, x into 1 minus y into log x, y square divided by x into 1 minus y log x. See, option B is correct. See, now here we can use shortcut form. I will give you one shortcut result. See, suppose given result in the form of y is equals to f of x to the power f of x to infinity form. Say derivative of this result is equals to dy by dx is equals to y square divided by 1 minus log y. See here, y, otherwise I consider, see, this is one more form result, y into f of x, y into log f of x into f dash of x divided by f of x, f dash of x divided by f of x. Or in some results we use dy by dx is equals to y square divided by 1 minus log y into f dash of x divided by f of x. See, now here, see, we can directly differentiation form that result. Suppose in the place of x, f of x is here, we have x term. Now here y square divided by 1 minus y into log of f of x. Here we have f of x. F of x is equals to x. See, derivative of this result is f dash of x is equals to 1. Now substitute in this result, dy by dx is equals to y square divided by 1 minus y into log of f of x. Here we have x into derivative of f of x is 1 divided by f of x. Here we have x, 1 by x, or this result can be as y square divided by x into 1 minus y log x. See, option B is correct. You can follow direct differentiation form using power result. Otherwise you can use for this. Here we have only variable. Suppose given results in the form of constant term and variable, you should take log only. Don't use this shortcut result. Okay, next example. X e whole to the power y is equals to e to the power x. See, now here we have power form u to the power v result form. Now take log on both sides. Take log on both sides. Log of x e to the power y base is understood is equals to log of e to the power x base e. Next, see, a to the power b form, b into log a result, y into log of x e is equals to, here also, x into log e base e. See, you know the result. Log E base C is equals to 1. Now here you can substitute the value of this result is 1. Next, log of A into B. This result given as y into log of x base E plus log of E base E is equals to x into 1. Here also we have log E base E form. Here we substitute, the value is 1. Next, y into log x base E plus 1 is equals to x. Next, y is equals to x divided by, take two denominator right side, log x plus 1. So now here we differentiate with respect to x on both sides. Here we have to find dy by dx. Derivative of this result is equals to d by dx of u by v formula. See, denominator into derivative of numerator, log x plus 1. Derivative of x is 1 minus numerator into derivative of denominator. 1 divided by x, constant term is 0, 1 by x, divided by log x plus 1 whole square. Log x plus 1 whole square. Now here, x divided by x gets cancelled. We get 1. Log x plus 1 minus 1. See, I write here. This implies dy by dx is equals to log x plus 1 minus 1 divided by log x plus 1 whole square. See, plus 1 minus 1 gets cancelled. Here we get log x base E divided by log x base E whole square. You write base E, the base without base also, that is understood base E. See, here we have option C, dy by dx is equals to log x divided by 1 plus log x whole square. See, now without base means that is base E is understood. This is the correct option.